Hello. In this problem, a baseball is thrown vertically upward with a given velocity of 20 meters per second, and we are to find how high the ball can reach if the internal energy doesn't change, and what is the maximum height it can reach, maximum altitude it can reach. That is, we'll assume there is no energy that is lost as it goes from state 1 to state 2. At state 2, obviously velocity equals 0, and then it starts falling back and it comes down to the ground, and we'll call it state 3. So the question is, find Z2, what is the height, and then find change in stored energy, which is mass of the ball times E3 minus E1, where E is the specific stored energy. So what is E? It is U plus Ke plus Pe. And we know what the formulas for Ke and Pe are. Velocity squared by 2000 is Ke, and Pe equals Gz by 1000. The 1000 and the factor of 1000 necessary because you want unit to be in kilojoule per kg instead of kilojoule joule per kg. Okay, so we are going to use the DeskCal to solve the problem, and I have already written the code, so I'll just quickly go over how we, for instance, launch the app, and then how the test code will look like. So to launch the app, we simply go to Test Steps, DeskCal, and go here, and we can start writing the code right here. Obviously, the good practice is always to write a comment and divide the code into blocks, and that's what I want to highlight here. So in the first block, as you can see, I'm writing down the values that are known for state 1. The mass is known, the velocity is 20 meters per second, the height is 0, the elevation is 0, and energy, I'm just assuming internal energy which remains constant. I'm assigning it a value of 0. Answer will not depend on whatever value you choose. Just like the altitude at the ground level, I'm assuming 0. So notice how the variables are named. Variable name followed by unit. This is our standardized practice. Okay, for state 2, we have velocity is 0 because it has reached the top, the peak, and internal energies are equals because energy is constant. For state 3, when it returns, the velocity is 15 meters per second, and the height is obviously the initial height, which is 0, and specific internal energy, small u, remain unchanged. So we have figured out state 1, the values given in state 1, 2, and 3. Once you click the calculate button, it will show that all these values have been registered. So now the calculation starts. Find E1. So basically, if you write, you can expand the comment. E1 is nothing but what? E1 plus Ke1 plus Pe1. And that's the physics. In computer code, what we are doing is we are putting the unit to remind us what units we are using in both sides of the equations. So gravity in meter per second square is 9.81. We declare that here. So Ke1 is, as you can see, is the velocity squared by 2000, as we know, to get the unit corrected to kilojoule. Pe1 is g times altitude by 1000. So therefore, specific stored energy is U plus Ke plus Pe can be found here. Similarly, now that we know E1, we know that the energy doesn't change. The stored energy remains constant as the ball goes from state 1 to state 2, because there is no energy lost or gained during this process. Because we want to attain the maximum height, we'll assume there is no friction at all. Obviously, if there is friction, E2 will be less than E1. Okay, so using this, we know what is E2, they're equal, E2 equals E1. And therefore, now that we also know what is Ke2, because velocity at 2 is known, Pe2, we can figure out the altitude Z2m from the energy equation, because after all, what is PE2 is known from the fact that, if you want, you can write a slight comment that because E2 equals U2 plus KE2 plus PE2. And that's exactly the equation you have used to find PE2, and once you know PE2, you can find Z2. So therefore, the first part of the answer is found here. Similarly, to find the stored energy at state 3, we are basically doing U3 plus KE3 plus PE3. Therefore, E3 is found, and we could write a little comment here. E3 equals U3 plus KE3 plus PE3. Therefore, the change in stored energy delta E kilojoule is m kg times this, which is obvious. So delta E equals mass times E3 minus E1. So it looks like a lot of work for a simple problem, but why we are doing that? Because once you learn how to divide the problem into blocks of ideas, then once you go over this, each step will become so clear to you. And not just that, more important is that a complex problem like this is a simple problem. In a complex problem, you can do a lot of what if studies. You can just go and say, what if the mass of the baseball was not 0.5 kilogram, instead it was 0.8? So all you do is you just go here. By the way, the answers are, for instance, how far it will go up. You can see it will go up about, what is Z2 we found? About 20 meter. So what if the baseball was not 0.5? Suppose we say baseball was 0.8. If we calculate, you will find the height will not change. It's still 20 meter because we are throwing it at 20 meter per second. That hasn't changed. But suppose we say we are throwing the ball at a higher speed. Let's say we say we're throwing the ball at 30 meter per second, which is pretty high. It's almost like 70 miles per hour. Then you can see the height raised will be much higher. It's 45 meter, 45.9 meter. So like that, you can do what if studies very easily once you have developed a readable code.